This video is going to help explain stoichiometry. Stoichiometry is where we use our mole-to-mole ratio in a balanced chemical equation to figure out what can be produced or how much of something we should have to start with in order for our reaction to take place. So I'm going to use the reaction of methane, CH4, plus 2 oxygen. It's going to yield CO2 plus 2 H2O. This is example problem number 5 from your handout packet, note packet that goes along with our stoichiometry unit. Okay. We have a hydrocarbon plus oxygen yields carbon dioxide and water. So this is a combustion reaction. Don't forget about our types of reactions. Those will come up again on our final exam. But this is a combustion reaction. Okay. And it's been balanced for us. So in my problem, I want to know what is the mass of water if I start with 500 grams of methane. Methane is CH4. I deduce that because I know oxygen, I know carbon dioxide, and I know water. So that leaves me with CH4 being methane. So I'm going from grams, CH4, my mass, and I need to get to grams of water. I pull out my Moldtown sheet and I realize, hey, I can't directly go from grams of something to grams of something else. I need to do some conversions. I first need to go from my mass, which is at the top of one page. I need to go down to get to moles of my methane. I then need to go across. I'm going across my causeway, my mole to mole causeway or bridge over to my moles of water, and then I can finally go from moles of water to grams of water. To move from grams to moles, I need to use the molar mass. And again, from moles to grams, I need to use my molar mass. And then moles to moles, I use my mole to mole ratio. And this is using the coefficients in the front of these compounds in my balanced equation. Every one of these arrows, here, here, and here, tells me that I'm going to need a box in my dimensional analysis, my unit cancellation. That's going to tell me that each one of these requires some sort of ratio, some sort of conversion factor. So I go ahead and I start with what I'm given, my 500 grams of methane, and I draw my fence. And I know that I have to go from grams of CH4 to moles of CH4. Then I know I have to go from moles of CH4 to moles of water. Then from that moles of water, I go finally to my grams of water. I have to go back and get my molar masses. My molar mass of CH4, I've calculated for you from the periodic table. It's 16.05 grams for every 1 mole of CH4. From my balanced equation, which was CH4 to O2 yields CO2 plus 2 H2O. Here, the numbers in front, my coefficients, that tells me my mole to mole ratio. My moles of CH4 is 1. My moles of water is 2. So I put 1 to 2. And then I use my molar mass again. I have 18.02 grams of water for every 1 mole of water. So when I plug and chug that into my calculator, I get the answer of, my final answer is 1122 grams of water I look back at my initial number. It has one significant figure, so now I can only have one significant figure in my answer. My first significant figure is my 1, so the number after that, since it's less than 5, I keep my 1, and I change everything else to zeros. So it becomes 1,000 grams of H2O. Now, would this happen in real life? Probably not. But this is how my significant figures work for my problem. So any other mole problems? Some mole problems will be stopping, and I'm just going from grams of something to moles of it. Other mole problems, I'm starting with moles of one thing, and I'm just going to moles of the other. And then I have my granddaddy of them all problems, like this one, where I'm going all the way from grams of one thing to grams of the other. So you just need to use your mole towns, right? And for every one of these elements, I could have a mole town. And I use my mole-to-mole causeway bridge to get from one element molecule to the other.